Hello there, math students, and welcome to our lesson on comparing linear relationships. We are going to be solving all of these problems the same way, and that is going to be by finding their unit rates. As you may know, I know you've had some experience with unit rates. Here are our steps. So first, we are going to find the slope, and then we're going to divide that top number by the bottom number, and that's going to give us a nice, neat unit rate. In this video, I'm going to go over problems 1, 2, 4, and 5. Let's get started. Okay, so for problem number 1, let's read it first. Who will have $100 first, George or Mark? Okay, it says George had $20 and was saving $15 every week. Over here it says Mark also started with $20. His savings are shown on the graph below. Okay, cool. So it sounds like they both are starting with $20, and then George is increasing by $15 every week. So let's write that as a slope, as a ratio, as a unit rate. So he's gaining $15 per every 1 week. So since we have a 1 on the bottom, this is actually already a unit rate. So this right here is our unit rate. You could say 15 over 1, or you could say 15. Okay, let's see what the unit rate for Mark is. So the first thing we need to do here is figure out the slope of this line. So here's a nice neat intersection point here, and there's also a nice neat intersection point here. And let's just draw our little stair step like that. So how much are we increasing here? We're going from 20 to 30, so that's going to be an increase of 10, right? So we'll put that for our top number for the slope. And then how much are we increasing here? Let's look down at our units. We're going from 0 to 1. Oh, looks like we're only increasing by 1. So we have a 1 on our bottom number. So I was trying to find the slope, but now I see with a 1 on the bottom, it looks like we already have our unit rate. You could write it like this, or you could write it just as a 10. So if Mark is gaining by $10 a week, but George is gaining by $15 a week, who's going to get to 100 faster? That's right, it's going to be George. All right, let's go on to the next problem. I'll go ahead and take this with me. We'll put it right there. No, we'll put it right there. Okay, we've got it. Let's read it. Put the cyclists in order from slowest to fastest. Note the variables x equals time in seconds and y equals meters traveled. Okay, let's keep in mind what we're trying to find here. We're trying to get the slope so that we can then divide it and get the unit rate, right? Okay, so for cyclist A, we have this nice little table here, and you guys know how to get the slope from a table, so let's just think through this really fast. Over here on the x side, it looks like we're increasing by 2 each time. What about on the y side? Looks like we're gaining by 1. Okay, so remember we're going to put the change in y over the change in x, so it's going to be 1 over 2. Now, is this a unit rate? Not yet, because the bottom number is not 1. So here, we're actually going to follow step number 2. Divide the top number by the bottom number. So grab my calculator. You may not need your calculator for this problem, but if you want to use it, that's fine. 1 divided by 2 is going to be 0.5. That's our unit rate. And I have not left myself enough room here, so I'm going to try to make that neat. So for cyclist A, our unit rate is 0.5. Let's go on to cyclist B. It says Bob has cycled 12 meters in the past 6 seconds. All right, so we have 12 meters in 6 seconds. So let's put our distance on top, because that's what we did over here. And our time is going to go on bottom, 6. Okay, now let's take this ratio, or this fraction, and make it into a unit rate. So we're going to do 12 divided by 6. Again, you may find you don't need a calculator for this, and that's great too. But if you want to use it, go ahead. That is going to equal 2. So our unit rate here is going to be 2. Okay, let's figure out the unit rate for cyclist C. Well, look at this. We have y equals 1/3 x. What is this all about? Okay, guys, this is an introduction to something really exciting called slope-intercept form. And it's really cool, and you're about to learn a bunch more about it later in this year. But let me go ahead and tell you what we're going to be learning right now. The number in front of the x So in this case, 1/3, this number right here that's sitting right in front of the x, this is always going to be the slope. So when you see something that looks like this, you have y equals and then some number and then x, that number right there is the slope of the line. So now that we know what the slope is, we can once again follow step number 2, divide that top number by the bottom number. Okay, let's do it. 1 divided by 3 is going to give us 0.3 repeating, and that is going to be our unit rate. So I'm going to circle it. Okay, one more left here on this one. Cyclist D. Okay, we've got a line here, and it doesn't really cross very well here or there, but right here we have it crossing at a really nice intersection point. So let's make ourselves a dot there, and we'll put another dot at 0, and we'll figure out the slope of this. It looks like we're going up 2, and we're going over 3, so our slope is going to be 2/3. And now let's divide. 2 divided by 3 gives us 0.6 repeating. And this is our unit rate, so I'm going to circle it. Okay, so now that we have unit rates, we can easily compare these 4 cyclists. Let's go back and read our question one more time. Put the cyclists in order from slowest to fastest. Okay, let me just move down a little bit. So slowest to fastest. And okay, so the person who's slowest would be the one with the lowest unit rate. So we have 0.5, we have 2, we have 0.3 repeating, and we have 0.6 repeating. So the lowest number there is this one right here, cyclist C. So we'll put him first, C. Okay, what's the next lowest? Definitely not that 2. Either 0.5 or 0.6. 0.5 is lower, so that's cyclist A. And next would be this one with 0.6, so that's cyclist D. And then the fastest one, by far really, is cyclist B. Okay, and that's the answer to that one. Let's move on over to problem number, not that one, problem number 4. Alrighty, so problem number 4, we've got this bathtub. It says, based on the information below, which bathtub will empty first and why? Okay, let's read it. Once again, we're going to be using unit rates. So for bathtub A, it starts with 25 gallons and it's draining 1.5 gallons a minute. Now let's look at the chart for bathtub B. At 0 minutes, it has 25 gallons, so it sounds like it starts at 25 gallons also. We'll figure out the rest of this later. Bathtub C, at first I thought this said 24, but when you look carefully, 24 is here. So this one up here is actually 25. So it looks like all 3 bathtubs start at 25 gallons. So whichever one has the biggest unit rate is definitely going to empty first. So let's figure out those unit rates. Okay, so bathtub A starts with 25 gallons and it's, well, we don't need to talk about that anymore. We just talked about it, so I'm going to cross it out. Don't need that information anymore. What is it draining? It's draining by 1.5 gallons a minute. So I'm going to put 1.5 per 1 minute. So I'm going to put 1 on bottom. Now when it's actually losing water, we're going to go ahead and indicate that with a negative, okay? And we're going to do that over here, but it's going to happen a little bit more automatically with these. With this one, we have to kind of think about it a little bit more. So we have a 1 on bottom here. So this is our unit rate. Cool. Let's go on to bathtub B. We've got this table, so let's find the slope from it. Looks like we're gaining 3 minutes at a time over here. Over here on the gallon side of things, we're losing 5 gallons at a time. So we're going to put the y value on top, or the change in y that is. And then change in x goes on bottom. Now let's divide. So we have -5 divided by 3. And that is going to give us -1.6 repeating. -1.6 repeating. So this is our unit rate right here, okay? All right, let's look at our graph. Okay, so where do we have a nice intersection point? Well, we have one at the beginning, and then not there, not there. Ah, here looks good. Let's draw our little triangle stair-step thingy. Okay, and now let's count. it looks like it starts at 21, 22, 23, 24, 25. So it goes up 1, 2, 3, 4. It goes up by 4. And well, it doesn't go up, does it? It goes down. Just kidding. So we're going to say -4. And then these units are 1, 2, 3. So it goes over 1, 2, 3. So our slope is going to be -4/3. Okay, once again, we divide. So I have my -4 divided by 3. And that's going to give us -1.3 repeating. Okay, so we have our 3 unit rates here. -1.5, -1.6 repeating, and -1.3 repeating. So whichever one is losing water the fastest is going to empty first. So which one of these negative numbers is biggest? And I say biggest kind of in that negative sense. It's losing water the fastest. So 1.3, 1.6, 1.5, it looks like this guy here is the winner. So bathtub B will empty first. And the reason why is because it's losing water the fastest based on its unit rate. Okay, that was number 4. We've got one left. We're going to do number 5. Okay, number 5. We've got some cars, and we're going to put them in order from fastest to slowest. Again, we have our variables. X is time, and Y is miles. Okay, we've got another one of these equations. Remember that fancy word that we talked about a minute ago, slope-intercept form? It's okay if you didn't remember that word, but if you can remember where to find the slope in this, then you are in awesome shape. I bet you do remember. What's the slope here? It's the number in front of the x. So if that's what you said, good job. So our slope equals 65. And 65 is the same thing as 65/1, so it looks like that's also our unit rate. So wonderful, we have our unit rate here. Again, you can say the unit rate as 65, or you can say it as 65/1. Both are totally fine. Let's look at car B. And I have a little misprint in here, so sorry. This should be 84, and this should say 2 hours. Hopefully your page is correct, but if it's not, go ahead and change it for me, okay? All right, so we have 84 miles in 2 hours. Let's put the 84 on top and the 2 on the bottom, and now we divide. 84 divided by 2 is going to give us 42. And this right here is our unit rate. I forgot to circle it up here. We'll just circle that. Okay, let's go on to car C. We've got a table, so let's figure out our slope. Over here, we're gaining 2 hours at a time. And over here, it looks like we're adding 150 miles. So we're going to put that change in y first on top. So 150 over the change in x, which is 2. And now we divide. 150 divided by 2 gives us 75. So we got 75 for that one. All right, that is our unit rate, so I'm going to circle it. And now let's look over here at our graph. Nice intersection points at 0, 0, and then we have another one right here at 140. And we'll just draw our little stair-steppy thingy and figure out our change in x and y. So how much are we going up in terms of y? 10, 20, 30, 40. So make sure you're looking at the units here to help you count, because it's not 4 here. It is actually 40. So we're going up 40, and then over, it looks like that's just 1. So it's going to be 40 over 1. So guess what? Because there's a 1 on bottom, we don't even have to divide. This is already the unit rate. Okay, awesome. So now we want to put them in order from fastest to slowest. Okay, so fastest at the top and slowest at the bottom. My goodness, that's messy, but you guys know what I wrote. Fastest car is going to have the highest unit rate. So which one of these numbers is highest? Looks like car C is highest, right? So we've got C. And then the next highest is going to be A. And then the next highest is going to be car B with 42. And then the lowest number there is going to be car D with 40. And that's how you do it. So all of these problems are solved with the unit rate, and they're going to be either like, I encourage you to compare them all with problems 1 or problems 2. problem number 2. So they'll either be like this one or like this one. And if you have any questions, please just ask your teacher. And thanks for watching. See you next time. Bye.